All right.
All right.
So it's been a long day for you guys, working with Unity and Windows Phone, Windows Store. No? Yeah?
Somebody seems pretty tired. So no.
So I'm Amir Ebrahimi, studio director at Luminary Productions.
I'm Marco, tech director of Luminary Production.
We're a small dev studio in
Yep.
San Francisco. I'll spare the backgrounds. We'll just get started. And so we're not going to be able to demo the app that we ported for contractual reasons. We will talk about what you can expect if you want to port to Windows Phone. And I apologize if some of the things that we're talking about were already talked about before we just got here. So unfortunately, we don't know what's been said. But yeah. So we could talk about first the app we ported took. We got on early on with the Windows Phone builds, and the app took about
I think it was the alpha, even not the beta.
Yeah, maybe 2 or 3 months
Yep.
of work, but that's off and on. So don't expect that much time to port your games over. So we'll start with the general approach.
Yeah.
Leave Mark with it.
So let's talk a little bit about the general approach in order to make a Unity game built for Windows 8. We experienced some problem with, as Amir said, we start with the Unity Alpha, and here is some general approach that people should use to build the game for Windows 8. The first thing that we experience is if you guys have already some game built in Unity 3.5, 6, or 7, for sure you guys should first porting as soon as you guys are going to port the game to Unity 4, just make sure it's running in the editor. I mean, it is pretty obvious to say, but it's not quite obvious to act this kind of stuff. So after that, what we experience is no assumption with Windows 8 and Unity, especially in the alpha version. Windows Phone, sorry, Windows Phone, Unity, especially in the alpha version, just because we experienced some problem. Like I remember we have some problem with our project with the touch, also with wait for second. For example, we try to build the game, and the game at some point should show something. But for some strange reason, the synchronization of the game wasn't right in the time. And go through the code, we just understand that was some built-in function in Unity that didn't work in Windows Phone 8. So what we did, actually, we cut in piece the problem. And this actually is a good use case, is a good work to do, just cut in piece the problem, just try to narrow where is the problem and try to find exactly what it is not working in the moment. The only keyword here is no assumption, no trust in both sides, Unity and Windows 8, Windows Phone 8. And another thing, also this works pretty good if you guys need support from Unity side. Usually, we have a little bit experience with them that people just send all the project, the entire project, and when Unity just get the project, say, "What the hell? What is that?" Just because they are so busy with the new stuff for Unity, they don't go through the code and just cut in piece the project. This means work really, really good if you guys just try to focus in the problem and narrow down where is the problem, cut in piece, and if in that time, even with the bug phase, you guys didn't find the solution, this will be probably the good project to submit to the Unity side. And I think this will be the general idea of the good approach. As Amir is the code guy, he will show you something about what we should do in the code between some constraints that Windows has with the back button and so forth.
Sure. I'm going to add one more thing to the general approach. So I mean, if you submit, well, first thing I want to thank Unity and Microsoft working on the project with all involved was really cool, and know that with it's cool that we get to open the doors, and for those of you who are on the open beta, it's cool that they're opening the doors to allow you to get in and start working with stuff rather than waiting till it's completely bulletproof when it's general release for everyone else. Know that if you're submitting any bugs, I'll just say this: the more razor sharp you are about what you need fixed, the more razor sharp you'll get a response and how to actually see that in an update. If you have something that happens some of the times, well, then maybe they'll fix it. So I would just suggest to narrow down whatever's occurring down to a sample project on your own that is guaranteed to happen every time. I think that would work best.
I will add, it just pops in my mind, there was a problem with the fog in that time, and it's pretty hard, there is some insidious problem inside and it's pretty good usually cut in piece what is the problem. Like, for example, for the fog, we been looking through the mesh, all this kind of stuff, trying to understand why the game wasn't look right. And that time we just defined the fog is no longer supporting Unity. And after we, as Amir said, we narrowed down what was the problem. Hopefully we got from Unity a good response with just a shader of the fog that we can apply in many stuff. Everything worked well.
Yeah. So for the webcast for later, we're going to focus on the stuff. So what we're going to do is talk about specifics. We're going to focus on the stuff that, regardless of Unity or regardless of the state of, if you're on the Unity beta, these aren't workarounds per se for Unity like the beta. These are more issues that you will have to implement regardless of whether you join and start developing apps when Unity's at general release. So I'll just start. So one of the things you'll need to handle is the back button on the phone. Most of your apps probably have soft buttons for going back through your app, and I believe you're going to have to. I mean, I don't know. Maybe some of your apps will pass. It depends on how strict Microsoft wants to be about the back button. But the user experience is that when you press that back button on the Windows Phone, it takes you back to whatever is important to be at. So, if you have a pause screen and you hit back, it should just put you back in the game. If you're at the main menu and you hit back, you might prompt before you exit the app, or you might just exit the app. So most of you guys are probably using NGUI, and what I would say, this is one way to do it. There are many ways you can solve this issue, but because of our need for this specific project to not modify the GUIs much and not introduce new things into the Unity scenes, we just simply added code to each of the NGUI. Most of you, if you're doing NGUI, you've got some kind of controller class that is handling like when you're turning on one button or turning off a button, or you're filling text for some of your labels. So I'll go first to the Unity side. You would create a class called WP back button, or whatever you want to call it, and simply we add these components to the NGUI classes that normally would have the back button. We found that this was a quick way to. You probably have somewhere in your code like an on click for that back button. So the best way for us to do this without modifying a lot of the code was simply to have that back button press that click for us, so to do an on click. Now, so we just keep a little bit of state back pressed for that. That gets set on the Windows Phone side, and then we broke it into two calls, an update and a late update, because it was possible in the app to have modal windows that pop up, which were also NGUI, and so and I'll go back to the previous slide to show you how we are passing these messages through. But know that like if you have a system where you have modal buttons like yes, no, and it needs to block off the other NGUI stuff, that you would want to process those alerts first and then process any additional buttons behind it. The reason why we had this is we had modal windows pop up and other windows underneath. You hit back, it actually goes back out of the modal window and out of the menu underneath it. So by breaking it into the update and late update, you have that chance to catch both of those. So going back, this would be on the Windows Phone side. You would just add this. This code comes out of the main menu. Main menu XAML.cs. And all we're doing is we're finding all of the objects of that type in Unity. One of the things you have to do is add the assembly. Well, no, actually the assembly will already be part of the solution, so you don't have to find that. You simply enumerate all those back buttons. And the two key points, okay, good, I get a mouse. We're just setting that state variable on that specific component that sits there, and that'll get cleared the next time Unity runs. And then what's necessary for Windows Phone is you have to mark that you're canceling this back key press. If you don't, the app is going to exit. So you just have to mark that. Now, in the case that we do want the app to exit, it's when we're on the main menu where there aren't any of these WP back buttons. And so cancel won't get set to true, and then it'll just exit out of the app finally. You have the option, too, to throw up a pop-up in that point if you want to ask, are you sure you want to exit the app? So that's the back button. Let's talk about the splash screen. What?
Oh, good.
Anything else?
No.
Okay. So the splash screen, I don't know the name of the previous presenter, but he had spoken from the Windows 8 side. Unfortunately, that won't work for Windows Phone because of the loading mechanism on startup. You don't get the load state. So you're on for splash screens on Windows Phone, you have to do it slightly differently. Unity puts a splash screen.jpg in the project folder, which is a default splash screen that will load, but it loads only when, I'm sorry, that's actually a Windows Phone feature. So that will load up until the point that the engine is kicked off. The problem about the engine getting kicked off is that Unity doesn't have like another splash screen to throw up right at that moment until, you could hook it once Unity finally starts up, and if you had a stub scene, you could have like some image display, but you're still going to wait like 3 to 6 seconds before you see that. So what we did instead was catch the main page. In main page XAML.cs, we catch the construction of that before we actually initialize the Unity side of things. So we just knew a splash screen control, which will be a custom XAML file that you create, and I'll show that next. And then we just set the width and height of that splash screen to match the application width and height. We set the control to, we set the pop-ups child to that control, so that's what's being displayed, and then we just set it to open. The splash screen, this you don't need to worry too much about. If you create a user control, most of this is filled in for you. The part that you're going to care about is the part inside the grid. So you're going to put an image here. You can name it splash screen or whatever you want. You would just add whatever JPEG you have here to your project. So it just needs to sit in the root of your Visual Studio solution. And the other part is the progress bar, which we just have vertical alignment bottom so that it will show up at the bottom, and then we use a margin to push it off from the bottom, so 100 pixels from the bottom. And then it's just going to be that default splash screen that shows the dots that slide by. So that'll cover all the loading. The final part is to turn it off once Unity loads. So this is code that Unity generates when you spit out a project from Unity. And the one key here is after we've set up all of this bridge stuff on the Unity side, the only code you add is this extra line here to turn off the splash screen once all that's been loaded. So that'll cover you for passing cert so that you have a splash screen for the whole loading period. Okay, background music. This one I don't know if you have background music in your game, then it's possible for someone to be playing background music on their phone when they go into your game. And it's preferable from the Windows search side that you respect that and don't play your own background music. Now, what's odd about this is from Windows Phone 7, a lot of these things were based on XNA, but XNA is deprecated in Windows Phone 8. Yep. So the workaround for this, and we played around with this a bit and finally figured it out, was that you actually have to service the XNA message pump in order to check this game has control property. If you don't, an exception will be thrown. So simply throw 2 of those XNA framework dispatcher updates in there, and then pull back from the property whether the game has control or not. And so that's what you need on the Windows Phone side. Again, that can go on your main page XAML.cs file. And then in the same file, the main page XAML.cs, you need to just hook that call into something. So in this case, this is still the same method, this drawing surface loaded, that Unity initializes itself in. This is just later down in that file. We're just finding object of type, and you probably have some kind of audio manager you've written, and simply hook up some event. Hook up your Windows Phone method to some event on the Unity side, so that when you're in Unity, you can check that, make that call, and it can return whether you could play background music or not. And I'm not going to explain the mechanism for how to talk from Windows Phone to Unity and back. There are examples in the Windows Phone beta and Windows Store 8. There are examples of how that interaction works. But pretty much, you have to hook from the Windows Phone side to Unity. You have to use events. It's a misuse of events, but it works quite well. You're essentially hooking that event and turning it into a function call on the Unity side. So you wouldn't want to hook more than, I think the behavior is if you hooked more than one, only the first one is going to return a value. So if you do have return values on those functions, you would only want to hook one of those.
So.
Yeah, been running for a while.
Yeah, it's pretty cool.
So let's switch to in-app purchases.
So I will just introduce the mechanism of in-app purchases, of course. Since Amir is the code guy, we'll go through the code.
The code guy?
Yeah,
I think you're technical.
That's okay. So, by the way, I'll work out the process of the in-app purchases. Usually what you are doing, as soon as you have, of course, built in your in-app purchases in your game, the process is as soon as your user will buy some coins or something in your game and hit the button, everything is managed inside the Visual Studio. You just define the method that have to communicate with the Microsoft server. The first thing you will do is ask for the list of license of your product. And as soon as you get back the list of the license, of course, you throw the purchase screen. The user will purchase the product. And when they fulfill all the process, go back to the phone. The phone communicate back to the game that was fulfilled all the process. And as soon as the game, of course, store locally the license, the product, and upgrade all the UI stuff that you have in your game, go back to the phone, and the phone go back to the server with the confirmation that everything was fulfilled, that the product was just purchased. That's it.
Okay. So we'll show you a little bit of the code. Again, this would be only for consumables because that's what this app needed. You might do, you can have other products too. I don't know if subscriptions were in there, but I do know they have, I forget the term they use for like non-consumables, but you have non-consumables too that you would purchase. Durables, yes. Durable. Okay, so what are these? I'm not showing the hooking part. Know that all these methods you would hook. Well, the handle product request is something you would hook as as an event on the Unity side. This is what would fulfill the Unity side. So we'll just run through some of these, why this stuff is here. So the dispatcher begin invoke is because we have to have this method called on the correct thread. So by using that, we achieve that. The synchronization context is something that, because exceptions can occur, this allows us to catch them. However, and I haven't changed the code because this works, I believe that might only be an issue when you have the debugger attached. So exceptions that were occurring from Windows Phone Store were causing crashes in the application, and judging by some of the comments on the Windows Phone forum, it seemed that like other people weren't having the same experience when they were running without being hooked up to the debugger. But this works in both cases, so that's why we have it. And to find out async synchronization context, that's well documented. That's not something we came up with or anything, so I'm leaving that code out. The load product listings is where we get into the interesting stuff. So it's an async method because it makes a call out to the Windows Phone Store. We load listing information async. In your dev account, you'll set up your in-app purchases. You'll set product IDs for that. You can filter those if you want by passing an argument to this method, or you can get all of them back. In this case, we get all of them back. And we're preparing a dictionary of prices based on the product IDs. So we're simply going through all the products, setting the price, and then we're giving a call to Unity to update those product prices. So we got a bit of connection where Unity's calling out to us to handle the product requests. That's this method. And we hooked an event for that. But then we also are calling back into Unity a method that that is on that specific object. So my game can be whatever manager you have. You would do a find object of type my game. You would store a local reference to that inside your Windows Phone, inside your Visual Studio project, the Windows Phone class that you have for handling in-app purchases. So that's handling the product request. Handle purchase is very similar. Again, same kind of invoking the method. One thing I'll point out, if you try and test your in-app purchases without having your app ID set, you will get an exception. And it's an exception you won't know. There's not much information. So know that if you get an exception when you're trying to call any of these methods, make sure you have your app ID set in your WM manifest.xml. And then if you don't have Wi-Fi or connectivity, you'll get another exception, which won't be very informative. And know that basically setting the synchronization context is important, or handling those exceptions, because it'll crash the app otherwise. Even though Unity has at the highest level like a exception handler to catch those, it still crashes the app. So so just want to make a note of that. For handling a purchase of the product, we wanted to make sure you can ignore some of this stuff. Like we used I forget what mechanism it is. It's some kind of locking mechanism. I think it's a slim semaphore for that, but we're just keeping track. We only want one purchase to go through at a time. So, it's interesting. We left the code in because it works, but at the time, NGUI had an issue where it was sending 2 button presses to every button. And so we saw that issue later, but because we were having this early on, we went ahead and bulletproofed it by only allowing one transaction to happen at a time, because bad stuff happens if you kick off 2 product purchases at the same time. So, so that's why we have this lock. We do a fulfillment of any purchases, because sometimes there may be purchases that were made that weren't fulfilled from a previous session. Some odd thing could have happened, like your app crashed after they purchased. So you actually need to clear those before you purchase the next product of the same ID. It's not possible to purchase a consumable until you've cleared the previous one. So, and we'll show that method in a second. And then the next part is just request product purchase async. This makes a call to Windows Phone. store, it'll pop up a window where they actually go and choose to purchase or not purchase that. And then we actually fulfill that again. If they did make the purchase, it would fulfill that. So do fulfillment. What you'll get back is from the app, you'll get back the product licenses. And from there, you walk through each of the products. And if the license is active and it's consumable, then that means we can use it. So we make a call back to Unity, report that that product was purchased, and then we report to the Windows Phone store that we fulfilled that product purchase. So it's pretty easy to get your in-app purchases going with Windows Phone. So the other thing to keep in mind too is that when you're submitting, you need the app ID in the manifest in order to test out your Windows Phone purchases, but you're not going to have that until after you start this, you create the app in your developer account. Now the odd thing is if you create the app in your developer account and upload your Zap and submit, whatever Zap you made isn't going to have the app ID. So it's a chicken and egg thing. You basically need to back out of whatever process you're doing when you're creating your app for the first time in the store. Go to the details page, grab the app ID, copy that back into your project, build again, then upload it to the store. So it's just a process you have to, and that only happens on the first time. After that, obviously, you'll have your app ID. One other point that I should make, if you create a beta product and you're using the beta to test with your players, and you want to have in-app purchases in that, know that that beta product you cannot make into a full product. You're going to have to enter all your same in-app purchases. You're going to have to create a separate app for that. So be aware if you are going to go down that path. Conclusion. Yeah, I don't know. I mean, it was a relatively smooth process, considering, I've seen other alphas, and alphas can be pretty hairy. This stuff worked for the most part straight off.
It's improving right now a lot.
Yeah,
what they are doing with the beta version.
And I would say, again, just big point, if you're Unity 3.5, definitely upgrade to Unity 4.0 before you start your porting effort. Don't mix the two. In fact, I would suggest using, definitely use, we were using Git on this because it's really quick. It's really quick source control. But make tons of different branches for the experiments you try. If you are like on the beta. If you're getting the general release, you're probably just going to hit build and it, other than the stuff you have to do on the Windows Phone side, you'll hit build and it should just run. I don't think. I think. Open up to questions.
Seems.
So.
You use Android on phone app?
What's that?
You used Android on your phone app?
On Windows Phone, yeah.
Yeah, we use Android on Windows Phone, yeah.
Since
you were pretty clear, nobody.
You know what? I'll throw out a few more things just in case, just like that you might encounter. So the fog one, Marco mentioned, you'll need to integrate that into all your shaders if you want to have fog. Another gotcha.
Also make sure you apply all the objects that are affected of the fog with the shaders, just because, just go.
To switch your materials for all those. Another one is the log files, or you can get to them with the Windows. There's the Windows Phone tool. You can get to all your log files that way. A quick thing just to save you time, you won't see the log files update, but know that you can keep clicking on your log files, and even though it shows an old timestamp, it'll give you the correct one. I'm just trying to think of any of the things that would wasted a lot of our time that would be worth sending. Well, if you come across something or wondering, email one of us, and we'll be happy to let you know if we forgot about that and we encountered that. So, all right, thanks.
Thanks.
Yep.